Ms.Hearn. Let's get started.
In this video, we're going to take a look at solving two-step linear equations that contain decimals. So, for example, if we had 0.3 plus 0.5x equals negative 1.2, it can look a little intimidating when you're asked to solve an equation that has either fractions or decimals in it. So one technique would be to actually clear those decimals. And the way that we do that would be to look at the number of decimal places in each number. So in this case, all three of the decimal numbers have one decimal place. Remember, that's the tenths place. In other words, 0.3 is the same as 3/10. And so if we multiply by 10, we actually clear the denominator or the decimal, moving the decimal one place to the right. So let's try that. So distributing the 10 to both parts of the left because there's addition, we have 10 times 0.3 is 3, plus 10 times 0.5 is 5. The x is still there. 10 times negative 1.2 is negative 12. So at this point we have a regular simple linear equation that you're probably accustomed to seeing. And so we use the technique of getting the terms with x's on one side and the numerical terms or the constant terms on the other. In this case, I'm going to subtract 3 to get it over there with that negative 12. Being very careful with my signs because negative 12 minus 3, they both have the same sign, so we sum to negative 15. And then to get x completely by itself, we need to divide by 5 because 5 is being multiplied by x. The opposite operation there would be division. So finally, we have x by itself, and x is actually equal to negative 3, which means that if we were to plug negative 3 into the original equation, it would make the statement true and keep it balanced. Now, this is definitely not the only approach. If you're comfortable with decimals, and a lot of that has to do with whether or not your particular math course allows calculators. But if you're comfortable with decimals, you can just work with the decimals. So let's try the same equation. 0.3 plus 0.5x equals negative 1.2. But instead of multiplying through by 10, I'm just going to leave those decimals there. And I'm going to follow the usual steps of getting the x terms on one side and the numerical or constant terms on the other. So I'm going to subtract 0.3 from both sides, again being careful with my signs. So I have 0.5x equals negative 1.5. Dividing both sides then by the 0.5, we're going to get the same result. So we're going to have x equals negative 3. Or the solution set containing the number negative 3. Now there's one more thing that I need to mention. Not all equations with decimals have the same number of decimal places, so we will need to compensate. So let's look at two examples real quick. Okay, and how they would be different from the two we just saw, or the one we just saw. So for example, if I had 0.5 minus 1.25x equals 3.005, then in this case, the number of decimal places after the decimal is different for each number, right? So 0.5 has one decimal place, 1.25 has two decimal places, and 3.005 has 3. So if we really want to get rid of the decimal, multiplying 0.5 by 10 would work, but it's not going to work to multiply 1.25 by 10. That would only get us to 12.5. And likewise with the other decimals. So we need to look at the largest number of decimal places, and that's how many zeros we need to multiply by. So in this case, the largest number of decimal places is 3, so we need 3 zeros in our multiplier, 1,000. So multiplying through by 1,000 is going to move every decimal 3 places to the right, meaning we would have 500 minus 1 250x equals 3005. And then you would proceed, as we normally do, to solve the equation, subtract 500 from both sides, and continue from there. So if you want to use the technique of multiplying both sides through by a power of 10 that will eliminate the decimals, you need to have the number of zeros in your multiplier equal the largest number of decimal places.